asked to use the graph to estimate where the first, and by the way, this is f. Okay, this is a graph of a function. We're supposed to estimate where the derivative and where the second derivative are 0, positive, and negative. So let's write those off to the side and start with this. Where is the first derivative 0? Remember, the first derivative are the tangent lines. So where are the slopes 0? I didn't put any numbers on here, so let's just say this is 1, this is 2, this is, sorry, negative 1, negative 2. This is 1, this is 2. Okay, so where is the first derivative 0? Well, it's 0 right here because the slope right there is horizontal. It's 0. So at x equals negative 1, at x equals 0, and x equals 1, that's where the slopes are 0, right, where they're horizontal. And they want us to tell them where the first derivative is positive and negative. I don't know why, but I'm going to start with negative. Okay, so that means the tangent slopes are decreasing. They're negative. So if I draw a tangent slope right here, if we put a number to that, maybe it's like negative 4 or negative 3 because it's going down when we read it left to right. So negative, 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 negative. It's negative until we hit that horizontal tangent. So it's negative between negative infinity and negative 1. And then the slopes are now positive numbers, positive 2, positive 3, positive. And then they become negative between 0 and 1 again. So union 0 and 1. Wait. Yeah, we're doing negative. So they're negative between 0 and 1 as well, because these are negative tangent slopes. Okay, whereas the first derivative positive, that's just going to be pretty much the opposite, right? So it's positive, 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 positive. So it's positive between negative 1 and 0, and then union 1 to infinity. Okay, now where's the second derivative? 0. So this one's a little trickier. The second derivative is talking about the rate of change of the slopes. Okay, so when have the slopes stopped decreasing and started switching to increasing, or vice versa? So slope is negative here. Let's find another meaningful place where it changes. Slope's still pretty negative here. Slope's negative here. Slope's negative, getting close to 0. Slope 0. So the rate of change of the slopes right now is positive. Okay, because look, from here to here, what happened? What number do we have to add to those two slopes? This is like a negative 4 for slope. This is like a negative 1 for slope. So it's like we did plus 3 to go from those two slopes. That's the second derivative. The rate of change of the slopes is a positive 3 by my estimate. It's increasing, right? And now how about between negative 1 and 0? That's a plus 1. The second derivative isn't equal 0 there. The slopes are still increasing. How about from here to here? We went from 0 to positive 1. That's another plus 1 for a slope. Now how about from here to here? It's starting to get indistinguishable, right? Those slopes look to be the same thing. So the rate of change of the slopes is becoming close to 0 near x equals negative 1/2 on my graph. Okay? Because at some point here, the rate of change of the slope stops, and then it starts going back down again. They go from positive 1 to 0. So it leveled off, and the rate of change of the slopes became 0 between negative 1 and 0. Okay, this part's not as bad. Well, actually, it's still just as troubling. Okay, now let's do where the second derivative is positive. So again, do some estimation for these slopes. Like maybe this is like negative 3. Now what's this slope going to be? It's closer to 0, right? It's bigger than negative 3, maybe negative 1. So to go from here to here, it was a positive change in the slopes because it is increasing. So where the second derivative is greater than 0, so we know at least starting at negative infinity up to negative 1, the slopes are getting bigger. And then go from negative 1 to like negative 0.75, 0 to slope of 1. The slopes are still getting bigger. And now here's where the slopes have stopped getting bigger. They're hovering around positive 1 for a slope. This is 1. I don't know what I just said, but that's positive 1. That's positive 1. The slope is like maybe 1/2. It's starting to decrease now. So right around here at that inflection point that we just identified, the slopes have stopped increasing. And then the slopes start going down because you're going from a positive 1 for a slope to a 0 for a slope. So you're decreasing. So in the second derivative, where it's less than 0, we just found out at that inflection point that we identified earlier, -1/2 to 0, the slopes are decreasing. And then here we are at -1. The slopes are still going down, and now the slopes have started going back up again. So here's another switching point at around 1/2, +1/2 this time. The slopes stop their decrease. Okay, and now from 1/2 to 1, this is like a -1 for a slope. This is like a 0 for a slope, so that's an increase. To go from -1 to 0, you've gone up. And to go from 0 to 1, you've gone up. To go from 1 to 3, you've gone up. So it's increasing from +1/2 to infinity. So that's why I put it up here. There, now we've identified all those.